Okay, so we've all solved systems of equations before, but we've only done it when both equations were linear. So now we're going to move on to doing it with a linear equation and a quadratic equation. So learning goals for this lesson. I can determine the number of solutions that a system has when there is a linear equation and a quadratic equation, graph a system and determine the solutions of the system, and understand and explain the different types of solutions. Okay? So also added in here should be an obvious one, but just in case, we are also going to solve systems algebraically. Okay? Algebraically. All right, so moving right along. Oh, look, I had it in there. Silly me. Okay, so quadratic formula. We all know what that is. This is the type of graph it produces. Okay, there are three possible outcomes when you have a linear and a quadratic equation. So you have two solutions. So that's, hold on, let me do this. We have two solutions. We have no solutions. And we have one solution. So unlike two linear equations, we cannot have infinitely many solutions. Instead, we have two solutions. The other ones are pretty self-explanatory. They're the same kind of explanation that we got before. So two solutions. Remember from before, that is, the number of solutions are the number of places where the line intersects in this case, the graph of the quadratic equation. So we've got two spots there. We've got nothing here, so there are no solutions. And for one solution, it just touches. It does not go beyond that line, but they touch. They intersect at that point and only that point. So if you were asked to explain, you would just basically say that two solutions would be where the graphs intersect each other twice. No solutions would be where they don't intersect, and one solution would be where they do intersect. This is what you call a tangent line, where the graph of the linear equation just touches the graph of the quadratic equation in one spot. All right, so moving right along. Yep, we just covered that. So we have to determine the number of solutions for this system. Now, when you are not asked to do it algebraically, what you may do is use a graphing utility, such as Desmos. Okay? You put in your equations in Desmos, and you will notice that right down here, it intersects at one point. So we have one solution. So all you have to do is plug these equations into any kind of graphing utility and look for the points of intersection. It's as simple as that. Okay, now we would be asked to graph x equals 3 on the coordinate plane and determine the solutions to the system. So what we would do here is we would graph x equals 3. Okay, so it's just simply x equals. So which means it's going to be a vertical line right at 3. So this tells us where on the x-axis our vertical line is going to go. And notice it has one point of intersection right there. And it has one solution at 3, 4. So don't mix up your x and your y when you're listing your coordinates. That's where the solution's at. X first, then y, just like alphabetical order. All right, so what does it mean when a system has one solution? It means the graphs of the equations only intersect at one point. Okay, what does it mean when they have two solutions? It means the graphs of the equations intersect at 2 points. And what does it mean when a system has no solutions? The graph of the quadratic equation and the graph of the linear equation never intersect. So that's what it means. Simple as that. Okay, now we're getting into solving systems algebraically. So when we did systems of linear equations before, I suggested that you do elimination. I'm going to suggest that you do not do that here. Notice that they are both equal to y, which if you think back, you remember that you can set them equal to one another. Okay, and then what we're going to do is we're going to go ahead. So notice we have this here that we're going to have to take care of. You don't have to do this next step. I just find it a little bit easier. But I'm going to go ahead and add 4 to both sides right now, which will give me 2x plus 9 equals x minus 3 quantity squared. So what I'm going to do now is I'm going to expand this. So I'm going to basically do FOIL on x minus 3 times x minus 3. which is going to give me x squared minus 6x plus 9. And we want to move everything. So everything on the right side will go to the left side. Or vice versa. We can take everything on the left side and move it to the right side, whichever we find easier. In this case, it might actually be easier just to move these two over to the other side because we have 3 terms over here and our x squared is already positive. So we'll do that. We'll subtract 2x and subtract 9 from both sides, which is going to give us 0 on the left side equals x squared minus 8x. Because the 9 and the negative 9 cancel out. Negative 6, negative 2x, negative 8x. And there was no other x squared. And then what we're going to do is we can factor an x out of this because notice they both have x in them. So I'm going to go ahead and I'm going to put it back the way that I'm used to seeing. So I'm just going to move that over there, which you can do easily. And then what you essentially have is x equals 0 and x equals 8. You have this x out here is equal to 0. Okay? End of story. If you have a variable outside by itself and it's equal to the other, and you have 0 on the right side, you're going to have 1 that's equal to 0. The other one, remember, so we had take the x minus 8, set it equal to 0, add 8 to both sides, and that's how I got x equals 8. Now, just like systems, we are not done. It asked us to solve, which means we need to find 2 coordinates. So we need to find an x and a y. So what we're going to do is we're going to plug in first the 0 for x in this equation, because this is the easier one to do. But you should do it in both just to double check. But just for the sake of time, we're going to plug it into the 1. 2 times 0 plus 5. 2 times 0, of course, is 0, so y equals 5. So we've got 1 point of 0, 5. Then we're going to do the same thing with 8. 2 times 8 is 16. 16 plus 5 is 21. So our solutions are 0, 5, and 8, 21. So remember, again, x's go first. If you want to double check the other equation, like I said, 0 minus 3 squared minus 4. So if we plugged in the 0, which would give us negative 3 squared minus 4, which is 9 minus 4, which still gives us a 5. So that works. And then if we did that again down here, it would be the same thing. All right? Okay, again, we are going to solve the systems algebraically. And again, we are going to take our 2 equations and we are going to set them equal to one another. And again, we are going to move everything over to one side. So remember, opposite operations. So 2x minus 2x, they cancel out. Negative 13, positive 13, they cancel out. Then we've got our x squared, our negative 8x, and our positive 16. And again, just for the sake of consistency, because this is how I'm used to seeing standard form, I just kind of flip-flopped the 0, and my terms on the right, I moved them to the left. All right, so now what I'm going to do is I need to use a quadratic formula is probably the easiest thing to do here. You could use completing the square. You could try factoring it first. It wouldn't work in this case. You wouldn't be able to factor this. Well, yeah, you know what? You could. You could factor this. So we'll take a look at that in a second. But using the quadratic formula, we can do a equals 1, b equals negative 8, and c equals 16. So when you plug everything in, this is what you get. You start simplifying it down. This negative 8 squared is 64. So that's a positive 64. Negative 4 times 1 times 16 is negative 64. So that gives you 0. They actually cancel each other out, and you have the square root of 0. This is an example where you're going to have one solution because 8 plus or minus 0 over 2 is just going to give you 4. So there's only one answer, because even with the plus or minus, in both cases, all you're doing is adding or subtracting 0. So that becomes 8 over 2 no matter what, and 8 over 2 simplifies to 4. So this is an example of one solution. 2 times 4 minus 13. It's going to give you negative 5, so your solution is 4, negative 5. Now, I did notice that this is a perfect square, this right here. That can simplify if you notice that, and it happens. So you can take x squared minus 8x plus 16, and you could make that x minus 4 squared. So we're going to go ahead, and this is basically similar to doing, completing the square, except we're just kind of simplifying this down to this, and then we would take the square root of both sides, which would give us x minus 4 equals 0. Add 4 to both sides, and you still get x equals 4. So either way that you want to do it is fine. All right, and that should actually be example 5, not 4. All right, so if there are any questions, this section was pretty straightforward as far as everything goes. But if you still have any lingering questions, please do not hesitate to let me know. Thank you, guys.